Today. Okay, for those of you listening at home, hi Julia. Yeah, thank Jana for this. I spazzed out almost too late. So we're going to do problems 5, 6, and 7 on homework 8. No. What's it called? What's it again? Yeah, 8B-1. We already did 1, 2, 3, and 4. This is 5, 6, and 7. Number 5 and number 6, we had to undistribute the 2. And it came here. This just got half as big, so half of 5 or 4 of 5 or 8. Here we undistributed the 4, so it got 1/4 as big. Multiplied by a fourth, 2 5 or 12 or 5 or 6. We just found all the various stuff on all 3 of these, and we're just about to graph. Ta-da! And thank God you can rewind this video. And don't forget to click like and subscribe. So we're looking at, click subscribe. You don't have to click like unless you like it. The baseline is 0. I'm just going to put a dotted line there.
What about post notifications?
Turn on.
I need to turn off my post notifications because I get like, every time you upload them, I get like 4 notifications. It's like, this is for algebra 2 and calculus. And I'm like,
Oh,
none of these
right.
are relevant for me.
Sorry. The amplitude is 1/2, so it's going to go up to 1/2 and down to -1/2. Now it is going to be going over pi over h to the left. So it's going to be a negative pi over 8. I'm counting by pi over 4s, which is really 2 pi over 8. Helpful to get a common denominator with your horizontal shift. So I'm going to start counting 1, 2, 3, 4, 5, 6, 7, 8. So 8 quarter periods. I'm jumping by 2 pi over 8 each time. This is 1 pi over 8, 3 pi over 8, 5 pi over 8. If these numbers are not correct, please fix them on your work, because this is going to be at least half of your points on the test. 9 pi over 8, 11 pi over 8, 13 pi over 8, 15 pi over 8. Okay? So we've got the baseline, and we've got the amplitude covered. We've got the horizontal shift covered. We have the quarter period covered. All I need now is to find out what kind of a graph is it. What kind of a graph is this thing? Is it positive sign, negative sign, positive cosine, or negative cosine? Positive what?
I mean, that's usually.
Positive sign. What does that look like? Where does it start? Where does it go?
Start at the base.
Yep.
And then go up.
It goes up. Correct. That's your basic positive sign graph. There'll be a dot right on the center of the graph, which in this case is negative pi over 8 times 0. Am I going to put a dot above that center, on the center, or below the center? Jacqueline?
It's signed, so you go on the center.
On the center. Where do you go from there?
Above.
Above. So max, base, min, base, max, base, min, base. And now draw a smooth, curvy line. No sharp, pointy teeth. Don't crash into it either. I think I just did. There you go. Make sense? So what I'll be looking for to get full credit. So you'll notice most of these graphs look alike. So what's going to make the difference? The scale on the x-axis is huge. The scale on the y-axis is not quite as huge, but pretty important. Where do you start? Do you start at the max, the baseline, or the min? That's important. And do you go up or down? Those are your main things. Once you have all those done, good to go. Number 6. Graph this thing. Again, we have a horizontal shift of pi over 6 to the left. So it'll be negative pi over 6. Baseline is 0. Amplitude is 3. So go up 3, down 3. Horizontal shift, got it? We're counting by pi over 8s. Can somebody tell me how to do that? Yeah, question.
Really quick, so do we have to simplify on the
over here.
Yeah, like,
Normally you do. These actually didn't, because none of them reduced,
if they did reduce and the,
and you didn't.
yeah, but I mean, just like on the number.
Correct.
Oh.
Yeah, on the x-axis, yes. That will not lose you many points. It might lose 1 or 2 out of 10 if you don't reduce, depending on how many needed to be reduced and if you did. Like if there's only 1 out of 12 that reduces or something like that, I'm not going to take off much, maybe 1. If like 7 out of 8 of them reduce, then I might take off 2. I'm starting at negative 5 or 6. I need to count by 5 or 8. Oh, yeah.
Get a common denominator.
Yeah, like what?
24.
24 sounds good. So I'm going to mark this as negative, whatever, 24.
4.
Yeah, negative 4 pi over 24. What am I counting by then?
3 pi over 24.
3 pi over 24. Now this is going to have some reducing action, but this is negative 4 pi over 24. Would the first dash make it past the y-axis or no? No, it's going to be right here. 1, 2, 3, 4, 5, 6, 7, 8. I would like you to try and graph them realistically. Do you see why the first dash has not cleared the y-axis? This is a negative 4 pi over 2. This will only make it to negative 1 pi over 24. Negative 1 pi over 24. That doesn't reduce. Then this is 2 pi over 24. 5 pi over 24. 8 pi over 24. I'm going to stagger these so you can see them. 11 pi over 24. 14 pi over 24. 17 pi over 24. And 20 pi over 24. Now the ones that do reduce, 2 pi over 24 is pi over 12. 8 pi over 24 is pi over 3. 14 pi over 24 is 7 pi over 12. And 20 pi over 24 is 5 pi over 6. Do reduce them all away. So good question. That one.
Land number 2 gives you, 5, I guess.
That's 5, sorry. Yeah, that's, wow. That's a horrible 5. Go ahead.
Why did you, like, skip numbers when you counted? Like, you went from 1 pi over 8 to 3 pi over 8.
Okay. We're counting by pi over 4. When we started at negative pi over 8. Now, I need a common denominator to have that make sense. So instead of counting by pi over 4s, I'm counting by 2 pi over 8. So I'm skipping every other pi over 8. So it'll be 1 pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8, because I'm adding 2 pi over 8 every time, which is really the same thing as pi over 4. Same thing here. I'm going by 3s because I'm really counting by pi over 8, which is 3 pi over 4. What kind of graph is this, Julie Black? Positive sign, negative sign, positive cosine?
It's positive sign.
Positive sign, correct. What does it look like?
Starts at 0 and goes back.
Starts at the what?
Oh, the base.
At the baseline and goes up. Good, because sometimes it's not 0. So, good. It's positive because the number in front is positive, and it's sign because it's sign. Yeah, Michael.
When you say you're using a common denominator, which is the 3 pi over 24 that, is that like with pi over 6?
Pi over 6, right. That's my starting point, and I'm going to start counting by, it's basically negative pi over 6, because it's a lot. Then it's going to be plus pi over 8, plus pi over 8, plus pi over 8, plus pi over 8. Well, what's negative pi over 6 plus pi over 8? I don't know. I had to find a common denominator. So I got 24. This became negative 4 pi over 24. And now I can add 3 pi over 24, and they actually match.
Did you divide it or something?
Did I what? Well, how do you find the common denominator with 6 and 8?
Yeah, I don't.
Oh. One cheap way to do it is multiply them. You can use something over 48, and then just look around and see if there's anything smaller that would still work. So the greatest the least common multiple, they call it. In other words, list the multiples of 6 for me.
So there's just 6, 12, 20, or
6, 12, 18, 24, 30. List the multiples of 8, just like the first four.
8, 16, 24, 24, 32.
Right. Where did they overlap first?
20.
24. That's why I used it. That make sense? Yeah. So then I multiplied the top and bottom by whatever I needed to get it up to 24. In this case, 8 times 3 is 24. So multiply by 3. And to get this up to 24, I multiplied it by 4. And then just multiply this to give us 4. And it's negative because we went to the left. Okay? And one last thingy, last hurrah. Here the baseline is actually not 0, it's 1 for a change. The amplitude is 3, so you're going to have a maximum of 4. You're going to have a minimum of negative 2.
Mr. Beckman,
Oh.
what's our graph number 6?
Oops! You're right. Sorry. So the center of the graph is here, negative 5 over 6, 0. And you said it was positive sign. So would you put a dot above, on, or below it? On it. And would you go up or down from there? Up. Max, base, min, base, max, base, min, base. You might notice that your graph can look a little different depending on how far apart you put your own spaces. If you use lots and lots of paper and you put your dashes really far apart, it's going to look really long and smooth. If you put your dashes really close together just because you're saving paper, it's going to look really fast and zigzaggy. So that's kind of an optical illusion.
Yeah, so on number 6, how did you get the 2 pi over 3 to pi over 2?
Which one?
Sorry, I was on the formula.
Oh, up here?
Yeah. No.
Oh, okay.
And then,
Here, what I really want, here's the form we need. Y equals A sine parentheses B parentheses x minus h paren plus k. This can also be theta. Same difference.
okay.
That's just the main variable. I need a variable in front with parentheses following, and they didn't do that. I had to undistribute the 4. That means I'm dividing 4 out in front. So basically 4 pi divided by 4, which is pi. And then 2 pi over 3 divided by 4. How do you do that? You multiply by 1/4. It'll be 2 pi over 12, which reduces pi over 6. Which is 6. Everybody get that? Now that I actually finished the problem. Okay, number 7. This also is what kind of a graph? Not meaning to be redundant.
Positive sign?
Positive sign. Where does it go? Where does it start? Where does it go?
Well, the baseline is at 1,
And goes
and then it goes up.
up. Correct. So the baseline is 1. What's the horizontal shift in this particular schema?
2,
Yeah.
yeah,
You're right.
2 over 6. No, oh, no, just 2, sorry.
Yeah, over 2. It'll be 2 comma 1 technically for the center, but the horizontal shift is over 2 to the right. What am I counting by?
3.
3s. So 1, 2, 3, 4, 5, 6, 7, 8. Da-da-da, da-da-da, da-da-da. I'm going to count by 3s, which is a heck of a lot more pleasant than counting by 3, 5, or 24. I'll admit. 5, 8, 11, 14, 17, 20, 23, 26. And since this is a positive sign, starts at the baseline and goes to the max, base, min, base, max, base, min, base. And there is your graph. Oops. Crashed into there. Makes sense? Any questions on this? Do you think you could do that on a test? That's the main point. Doing okay? All right, take your notes out, please. There's a college professor once told me, I think I told this story before, he had a really cool British accent that I can't really replicate
Try.
very well. I'm sure you've heard me say this before, but you may think you understand fully a particular branch of mathematics, However, in order to say that one has mastered a branch of mathematics, one must know it not only forward, but backward. So, can you do a problem like this backward? If I give you the graph, can you find the equation? That's our topic for today. Example. Find a valid equation for this graph. Now, put this graph in your notes as best you can. Doesn't have to be a total work of art. Trust me.
Which song is that? It's the one with the background.
What?
Are you sure? I think it's, what was it, what song is it like to be
Oh, no. I think those Alouette or something.
Oh, yeah.
Oh, I don't know why.
It's kind of like the ABCs, how there's like, Black Sheep, ABCs, or something. Yeah, that's true.
Awesome. Go ahead and graph that. The key points you may have to find on a graph. I'm counting by ones on the x-axis. While you're duplicating this, can somebody tell me where the first dot shows up other than the starting dot? Like how far over? What's the x value here? -1. What's the next one? 2. Next. 5. Next. 8. Keep going. 14. Now 16 is not a dot. I just ran out of space. Okay? That should tell you a few things. What seems to be the quarter period? What's that? 3. Prove it. Can anybody find the period just by looking at the graph? You can guess based on the quarter period, but by the way, I don't have to count by the quarter period on the x-axis. I mean, it's good. I can't count any faster than the quarter period, but there's nothing stopping me from counting slower. I could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That'd be perfectly legal. As long as I include the locations of the dots, I can put as many numbers as I want. Let me say it again. Up here, if I had put -1 and then skipped this one and then put 5, that would be wrong. I have to count by no more than 3, because that's a quarter period. But I can count faster than that, in a sense. I guess that's doing the metaphor backwards. I can count by ones if I want to. I can count by smaller amounts if I want to. That's perfectly okay. In other words, if you see the x-axis and you see I'm counting by ones, don't immediately assume that the period is 4. It might not be. The quarter period is how far apart each interesting dot is. That's a quarter period. How do you get an actual period? Well, I do it this way. Look for an easy place to find out how long it's been for one complete cycle. It's relatively easy to go from top to top. That's undeniably one complete cycle. How long is it? Like from what to what? What two numbers are we talking about? Paul?
From 2 to 14.
2 to 14. How long is that? 12. The period is the last one minus the first. You now know the period is 12. That's very useful. Let me just put that over here. Period equals 12. What's the quarter period then? If that's true.
The fourth,
Which is what?
oh, sorry,
Three. Make sense? We've got 2 out of the 5 things we need. Can anybody spot the baseline? Yeah.
3.
3. The baseline of what equals 3?
Oh, 1.
Y equals 3. Correct. Can anybody just looking at the graph tell me the amplitude? No.
2.
Yeah, how do you get that?
I just think from baseline to the highest point.
Right. From the baseline to the highest point, or if you wanted, from the baseline
To the middle.
to the lowest point, to the minimum. Either way, it's fine. In other words, this, the amplitude is 2, or this way, the amplitude is 2. It doesn't much matter, as long as you know the distance. What is, let me see,
Horizontal shift.
horizontal shift? You tell me. Go for it.
-4.
Yeah, it's 4 to the left. Pardon me. Is this making sense so far? What I want to do is recreate that A, B, H, and K. And these will help me do that. I'm going to use X instead of theta. Y equals A, parentheses, blah, 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 blah. Can anybody tell me which part of the graph influences the letter A? Sophie. Which part of the graph does A remind you of? Like what physical part of the graph is affected by the letter A? Sort of. What's that called? That's with the normal function. You're right, but there's a special name for it in periodic graphs. Jack Lund.
Sorry, what was that?
Okay. What does A affect on the graph?
A affects the amplitude.
Amplitude. Amplitude is basically the height of the graph, from the base to the max or from the base to the min. So A affects the amplitude. Just going to abbreviate that. The letter B, what does that affect? Michael.
Period.
The period, correct. It affects the period and the quarter period. What does H affect? Jenna?
The horizontal shift.
Horizontal shift. And what does K affect? Julie Miller?
The baseline.
The baseline. We should be able to reconstruct our equation based on this. Now there are a couple of catches. First, we do know that the absolute value of A is the amplitude. So A, can anybody guess what letter A? Just based on this stuff. Give me the value of A. 2. Or what? Possibly. I'm not, well, depends. Or negative 2. We don't know yet. It depends on what kind of graph it is. If it's a positive sign, we'll give positive 2. If it's a negative sign, we use negative 2, and so on. Can anybody tell me the value? Actually, let's go here. I should have done something first. K. Because I'm supposed to do that first.
Quick question, how are you supposed to know what sine or cosine?
Very good question. Assume that we're starting from here.
Yeah.
So what kind of a graph does it have to be? Starts at the min and goes up. What is that?
Positive cosine?
Positive cosine starts at the max. So what?
Negative cosine?
Negative cosine. This is a negative cosine graph. I'm gonna put a little negative COS.
So then 2 has to be negative?
Yeah, correct,
Okay.
correct. In this particular case, 2 is gonna be negative. Now, let me back up a little bit. We're supposed to do the baseline first. I should have done that first, although this is nice and easy. Can anybody tell me the baseline? Or what's the value of K? B?
What do you mean, like, K?
Just using this stuff.
Oh,
The value of K here.
3.
3, correct. Because that came from the baseline. Make sense? So K is 3, absolutely, no ifs, ands, or buts. A could be either 2 or negative 2, depending on where you start, what kind of a graph it is. Can somebody tell me the period? What's the formula for period again? Can you remember? Like when you have to find it yourself?
2 pi over b.
2 pi over b. Algebra people, I have a problem for you. I do not want e. I want b by itself. Do it. Yeah.
We make 2 pi over b equal, equals 12.
Say again, sir?
You can make the 2 pi over b equal 12 and solve for b.
Ah, okay. First of all, we know that p is 12. By the way, can you just get b by itself, just in general? That way we'll actually have a formula. You might be surprised by this formula, too.
Sorry, Mr. Coffin.
Go ahead.
I need to go.
Oh, okay, sure. And we're still videotaping, so it should be okay.
Okay.
So how do you get b by itself just using algebra? B, tell me out.
So you could multiply both sides by 2 pi.
You could, but that'd still leave b where it is.
Oh, could you multiply both sides by 2?
Yes, multiply both sides by b. So you get BP, no reference to the gas station, equals 2 pi. How do you get b by itself? BP, British Petroleum, that's it.
You have a gas station?
Is there gonna be a worksheet?
Not today.
Okay, thank you.
So, I'm sorry?
Sorry, sorry.
Oh, yeah. How do you get b by itself?
Divide by p.
Divide by p. Everybody please write this down. This is actually the moral of this problem. Gentlemen. B is equal to what? Somebody read it out. 2 pi over, no, just the formula. Why, yes. As a matter of fact, you can. Jonah, can you please go to the office? Okay. There's one other thing. There's a quick shortcut. I may not remember this. Let's just say m is equal to n over z.
What does that mean?
I'm just picking 3 random letters.
Oh.
Look up here.
Oh, no.
There's a rule that says that you can trade the answer and the denominator, and it'll always be true. Let me prove it to you. 10 over 2 equals 5, right? 10 divided by 2 is 5. Swap the bottom with the answer. What do you get? 10 over 5 equals 2. Does that work? Yeah, always. Look over here, and I know you're feeling tired and unfocused. Focus yourself. If you lose this, the test is going to be very unpleasant. The formula you've already memorized is P is equal to 2 pi over B. The other formula is B is equal to 2 pi over P. Just swap the P and the B. This is how we're going to get our B. So tell me, Pete, B is equal to what in this particular case? 2 pi over 12, reduce it for me.
So you get
Pi over 6. That's not the period. That is not the quarter period. It's the value of B. That's the number you're going to put here. Let's see what this thing looks like. Y equals, by the way, did we settle whether it was 2 or negative 2? We settled it was negative 2. How do you know that?
Because of where the graph starts.
Yeah, we started on the min. And so it has to be a negative cosine graph. So fill that in. What is A from beginning to end?
Y equals -2.
Negative 2.
Cosine.
Cosine, very good. Pren what?
5
Pi
over 6.
over 6. Paren. X minus, leave that blank for now. Paren plus what?
3.
3, because that's the baseline. Can somebody tell me the horizontal shift? Look at the starting point. It's relatively easy.
-4.
Yes. This is supposed to be a minus. Look up here. X minus -4. You have just found the equation of graph. If you graph that on a graphing calculator, it would mimic this perfectly. Take a, let me see. That would be equilibrium. Now, I do have a little bit of a surprise for you. Well, I suppose I should say a shock, depending on the point of view. We said this was a negative cosine graph, right? And yet that allowed you to get two things. And he said, oh, it has to be -2 for A. And oh, the horizontal shift has to be -4. Everybody look up here for a second. I made a horrendous error. I'm so sorry. This was actually the starting point. Can you give me the real equation now? If it starts here, what kind of a graph is it?
Positive sign.
Positive or negative sign?
Oh.
Good.
Positive.
Positive sign, how do you know?
Because it goes up.
Yeah, it starts at the base and goes up. Yeah, I apologize profusely for this positive sign. Yeah, it's not negative cosine as far as I know. Positive sign. What's the value of A? Almost. It's not -2.
Oh, it's positive.
It's +2, because it's a positive sign graph. And then sine or cosine? Yes, now we've just corrected my error. Parentheses what? The period is still the same, so you don't have to mess this up. Michael, take over. What do I put here?
5 or 6.
Yes, 5 or 6. Do you see why that doesn't change? The period of the graph didn't change, no matter what my error was. Keep going. Where is the real horizontal shift? Polly.
That's cool.
Nope. Where's the real horizontal shift? How far over is it when it started? This was -4. If I started there. Don't work too hard. How far over is it from 0? No, that's this. And this was my mistake. Here's where we're really starting from.
Oh, it's just 1.
1. 1 or -1? Yeah, here's 1. It's starting at -1. X minus -1. Pren plus, what's the baseline?
Baseline is 1.
I'm sorry?
Sorry,
So,
3.
to hurry back, yes. Okay. Let me say again, this is the point where you should be making a connection. If you allow yourself to just get spacey and detached, this is not going to end well. The test is going to be really, really hard. I've given this test for upwards of 20 years. I know exactly what it's like. And if you don't make this connection, you're going to try, it's kind of like with the ACT. If you know how to multiply, but you don't know how to multiply fast and accurately, it hits you hard. Let's say you get a test question, they're going to assume you're going to be able to multiply 5 numbers in a row, boom, 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 boom. If you have to struggle to say, okay, 8 times 7, is that 48, is that 52, is that 53, is that 56, I think it is. You're not going to finish the test. In this particular one, if you muscle through and say, what's the horizontal shift? Is it 3? Is it 2? Is it 3? No, horizontal, no, that's the amplitude. You're not going to finish the test. You're not. This particular problem, once you get this trick, you can do 4 problems in the course of about 45 seconds. If you don't get this trick, you're going to take the next 20 minutes doing those 4 problems, and you're going to run out of time. Trust me, I've seen this happen many, many times. Let me just, now focus again. Where do I get this number from? The -4? No.
That's the horizontal shift
Right.
from the first one.
From the very first step. Right. And then I said, oops, my bad. I'm supposed to be starting from here instead. What's the new horizontal shift? Tell me.
That's
-1. If I started at this point, hypothetically, what would the horizontal shift be? 8. See? You just pluck where, however far over it is. Horizontal shift means how far it's shifted horizontally. So whatever number you're at, that's h. So it's that easy. The amplitude has not changed, so it's always 3. So a is either 3 or 2, sorry. It's going to be 2 or -2. The baseline is always going to be 3. But depending on where I start, it's going to change whether it's positive or negative sign, positive or negative cosine. And it's also going to change the horizontal shift. Everything else stays the same. Now, do you see where we got this from? I'm so sorry. I made a mistake again. This is really the starting point. You can probably figure out what I'm doing now. Michael, what kind of a starting point is this? Is it positive sign, negative sign, positive cosine, negative cosine? It's a positive cosine start. So at long last, we know what it really is. Can you please tell me the equation for positive cosine? It's y equals what? First of all, positive or -2? Definitely. Sine or cosine? Cosine. What's the next thing? Good. What's the horizontal shift?
It's 1.
1 is here.
Oh, 2 is
It's 2. So what should I put here?
minus 2.
-2. Pren plus what? You see what it is? Oh, darn. Chucky darn. This is really the starting point. Shelley Miller, what kind of a starting point is that? Negative sign. So at long last, after all the 3 errors that I made, it's really a negative sign graph. Okay. Can you give me the equation? What number?
-2.
Yes.
Sine
Good.
of 5/6.
Definitely 5 or 6. What's the new horizontal shift?
X minus
5. Pren.
plus 0.
Done. Here's my question for you. You see this wavy graph? Up and down, up and down, up and down. Here's my question for you. Is it a sine graph or is it a cosine graph? You tell me. Here's what I do.
Wait, the one that you drew originally? Like
No, just the whole thing.
Oh,
If all I do is just draw this and I don't even circle any points, I'm just saying, well, if we don't know, because remember the thing is it goes forever. If it goes forever, how am I supposed to know if it's positive or negative or what? It's both. It's all of them. Is it a positive graph or a negative graph?
both.
Both. Depends where you start. What if I started here? What kind of a graph is it? Positive sign. So what kind of a graph is it? It completely depends on where you start. What if I started here? Wait a minute. It's a positive cosine graph if I start from here. What if I start from here? Negative cosine. The only things that would change are plus minus in front, sine or cosine, and where you start. What I'm going to do on the task is give you an equation, or give you a graph like this, and then say, I want 4 equations for this. 1 sine plus 1 positive sine, 1 negative sine, 1 positive cosine, 1 negative cosine. Make sense? You're not having any homework tonight. I want this to soak in. I want the poor suffering souls at home to be able to absorb this and watch the video. Tomorrow I will give you a worksheet based on this with a whole bunch of graphs, and I'll say, give me 4 equations. Okay? Does it make sense, by the way, if I want a positive cosine graph, I see at least 2 options. Do you see 2 options? Yeah, well, almost. 2 and
Oh, you said positive cosine?
positive cosine.
Oh, sorry, you said positive sine.
Oh, okay.
2 and 14.
2 and 14. I could have done 2 cosine blah 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 minus 2, or I could have done 2 cosine pi over 6 blah 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 minus 14. It would have been just as accurate. matter of fact, this is a true story.
So we can do either on the test?
Correct.
Oh,
Either one will be fine. There was somebody at my previous school, you don't know, who just loved to make my job harder at grading tests. How often do you get another positive cosine graph? Like, what do you add to go from 2 to 14? Yeah.
The period,
It's what?
you would add the period.
Yeah, the period. Every 12, it repeats itself. So he thought it was hysterically funny to take 12 times some god-awful number, like 299,607, and then add it to 2, and then put it here. And just go, I have to grade the bloody thing. And it says, really? So I have to pull out the calculator and say, all right, is this really, honestly, to goodness, an actual positive cosine start? And usually it was. One time I got him, he just made a simple arithmetic mistake and he was off by 1. I said, that's a positive sine start, buddy, -7.
Minus
So,
7.
actually, I don't think I did that. Well, but he was just trying to be obnoxious. But he and I get along really well. But he was just saying, hey, he wrote on the bottom of the test, Mr. Cochran, you'll love this one. Ha ha. So, moving on. Please stand. Let us pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Alrighty. God bless your health, Julia. See you soon. God willing.